All right, guys, so we have the start of a new section, 9.1, which is polar coordinates. So this is going to be a little intro video, just some stuff that we'll need to know when graphing and in general about polar coordinates and the polar coordinate plane. So I have a screenshot here from Desmos of the polar coordinate grid. And you can see it kind of looks similar to, if you've ever seen a movie with like a radar or like the air traffic control, you know, like I don't know what's called in a submarine, I think sonar. But that's where polar coordinates come in handy. Anything that kind of works in a circular motion. So those things scan in a circular motion. To analyze anything that moves in a circular motion, the polar coordinate system, it tends to be much more useful. I don't have any firsthand experience with that. I just teach it, but that's where this may come in handy in your future if you ever end up going there. So a couple things you need to know about the polar coordinate system. The origin, we don't really call it origin anymore, so it still is 0, 0, and we'll talk about coordinates, but now it is called the pole. And I'll write some notes here, and you guys can choose to either write it or just know. So I'm going to say the origin is a fixed point, now called the pole. And the polar axis, we don't really have an x-axis and a y-axis anymore. So the polar axis would be the initial ray. So it comes from the pole and goes to the right. So like directly east. So this guy over here is called the polar axis. So we really don't have an x-axis and a y-axis anymore, even though a lot of times we'll refer to them because you know where they are as kind of reference points, but now we have a polar axis. So on a lot of graphs, like if you Google it, sometimes they'll just have that bolded, or that'll be like the only darkened line in the picture, other things. Okay, so polar coordinates are a little bit different now. They're still made up of two elements, but they're going to be in the form r and then theta. And we've kind of seen these before. So r, similar to radius, is now going to be what they call the directed distance. And what that means is it can be positive or negative, and it tells you the distance the point is from the pole. So it can be positive or negative. And then theta is going to be a directed angle, just like when we talked about angles in standard position or the unit circle, we had positive or negative angles. So we can have positive or negative theta here. And that's going to be from the pole to axis, like to wherever your point is. So the directed angle from the pole to your coordinate. So I'm going to like put a random point on here. Let's go right here. And this would be a point in the form r theta. So for this specific point, r would be like the radius of the circle that point's on. So for this point, r would equal, see that circle out there, 6. And theta would be the angle from, having some craziness happen on my screen right now. There we go. So theta is our angle from, I should really say, the polar axis to the coordinate. So for this one, it looks like it's 45 degrees. And since this guy's in radians, pi over 4. So this coordinate here would be 6 pi over 4. Now you might be thinking, right, there's other ways we could write that angle, and there are actually an infinite number of ways we can write points using any coterminal angle. So for angles, theta is positive if we spin clockwise, just like our standard position, negative if we went the other way. So another way we could name this point is if I went in the negative direction. So another option could be 6 negative 7 pi over 4 that would be. And since I said directed distance for r, our radius, there's actually another way we could write that. So I'm going to kind of add on a little note down here because a directed distance for a radius is a little weird. I'm going to try to explain it. If r is negative, so less than 0, then P, our point, is on the ray that is opposite the terminal side of theta. And I'll draw an example here. So I'm going to erase all this craziness on my grid so we can see it a little better. So let's say, for example, I wanted to graph the point negative 4 pi over 2. A couple ways we could graph it. So pi over 2, I actually like to do the angle first, but you could do the radius first. But I usually like to go the angle. So pi over 2 is up here. And then negative 4, instead of just graphing point, I don't know if you guys can hear the fire alarm going off in my town. It's pretty loud. But this point would be 4 pi over 2. If the radius is negative, we go on the opposite side of where that terminal side would be. So this guy is negative 4 pi over 2. And there's other ways you can write that point, right? Think about coterminal ways to write pi over 2, things like that. So you guys will be exploring that in the next couple slides.